Okay, let's look at the case of two objects that are traveling towards each other on a collision course. And what we're trying to find out is how fast will they be going after they are joined after the collision. To solve this problem, the equation we use is Newton's third law, conservation of momentum. m1 v1 equals m2 v2. What's different in this case is what the m1 v1 means this time, the ones, they don't mean object 1. Instead what they mean is before, and the 2's mean after. So the total momentum of the system before the collision, before they're joined, is going to equal the total momentum after they're joined. So what we need to first do is figure out what is the total momentum of this system right here before they collide. So let's just say that this object here has a mass of 12 kilograms and is traveling in this direction at a velocity of 4 meters per second. The other object has a mass of, let's make it 8 kilograms, traveling in the opposite direction at 10 meters per second. What we'll do is, let me make this a little bit smaller and move it over this. Whoa, no, don't do that, Eric. Okay, and what we need to do in this case is we're going to go ahead and find the, first we're going to find the momentum of this object. So what we'll do is we'll say mass times velocity, which is 12 times 4. That gives us 48 units of momentum for the first object, which is going in this direction. And we have 8 times 10 meters per second, which gives us 80 units of momentum going the opposite way. Now, since they are going in opposite directions, what we'll need to do then is we'll have to subtract the two, which gives us a total of 48 minus 80. 48 minus 80 is going to give us negative 32. Well, all that means is it's going in the opposite direction. What the negative means is we're going in the opposite direction than the 48. Since the 48 was going this way, the system is going to go that way, which is just because that's where the momentum is larger. So really, we just need to worry about this. It's 32 units of momentum. That's the value we're going to use here for m1 v1. So we'll then put 32 equals m2 v2. Let me just go to a new slide to try to get a little bit more room. Okay, now the two cars have collided, and remember the momentum was greater in this direction, so that's the direction they're traveling. Since the momentum of this part of the system was 80 and this was 48, this was larger, so they're going in the direction that it was traveling. Now, what we have is a total momentum of the system beforehand is 32 units, and that's what it's going to have to be afterwards as well. What we need to do now is solve for the velocity of it. What we have to keep in mind is we have a combined mass now. We don't have two objects, we have a combined object, and that has a mass of 12 plus 8, which gives us 20 kilograms times V2 is going to give us the total momentum of the system now. So all we have to do to solve for here is divide both sides by 20, and 32 divided by 20 equals 1.6 meters per second equals our velocity. That's how you do it, my friends.